Hello everybody, my name is Nick Trixwhite and welcome to episode 1 of the survival game series. If you haven't seen the first episode, which is the introduction episode, I highly recommend that you do so because I won't be repeating myself. I won't be going over any of the stuff that I talked about in the first video. But this is our first time actually getting into the Unity editor and making some stuff. So this is a fine starting point if you're not bothered about what I said in the first video. Okay then, we've made a little Unity project to start. I just called it Survival Game Tutorial Unity. It's just regular old 3D, but we are going to install some packages as our first thing. First thing you'll want is the Universal RP, because it just kind of makes things look nicer, really. That's the only reason why we do it, to get some nice post-processing effects and some good shadows. And some nice environmental lighting too. I won't really be doing graphics too much for this series, but it's just kind of nice to have. Because if you didn't know, default Unity doesn't look very good. We'll also be using the Universal RP because we're going to be making a few shaders with Shader Graph, and you need Universal RP or HDRP to use the Shader Graph. Once that's done, make sure that you've also got Shader Graph. It should come with the Universal RP, but just in case it doesn't, there it is. And the first thing that we're going to do is make a new folder, call it rendering, and we're going to create, in the rendering tab here, Universal Render Pipeline asset. Just call it something like pipeline asset. This stuff, we'll just want to enable HDR, render scale to 2, soft shadows, just increase the distance slightly, try 75 for now, and set the post-processing to high dynamic range. Now we can start making some stuff. Start with a plane. We make sure that the position is 0, 0, 0, and we'll do 70 by 70. There we go, so we've got a big old plane to test our movement code. Oh, actually, I did forget something. I forgot to actually put the pipeline asset into our build settings. So take the pipeline asset and put it here. Now you'll see that things immediately go wrong, and that is because the default Universal Render Pipeline material is different to the normal default material. So we'll just make a folder, call it materials, create a material, and we'll just call it default_mat. This will already default to using the Universal Render Pipeline now, so we can just drag it on. Now we add in a capsule, and this will be our player. So call it player, and also tag it player. Now we can create a folder called script, create a subfolder inside that folder, call it player, and create a C# script called player movement. Now just open it up and wait for Visual Studio to load, or whatever code editor you're using. I personally prefer Visual Studio because it's got good auto correction, which helps me out a lot. It's actually loading. Now it is. So, a few things first off. We're going to want to put require component type of rigid body, because we'll be using that later, and it's just nice to add in a few exceptions just in case you make a mistake later. Now then, I'm just going to delete that for now, we'll put it back later, but first thing I want to do is I'm going to set up our movement variables. So we'll make a serialized field, private float move speed. What serialized field does basically is it just makes sure that we can see it in the inspector and that we can change the value. Then we'll also do serialized field, private float jump height, and private float min slope angle. Then we're also going to make another header, and this will be cam variables. We'll make a actually that doesn't need to be serialized. Transform cam, serialized, vector2, cam sensitivity, vector2, cam x clamps, and we'll also make a private float rot x. That'll store our rotation for later, because we'll need that to clamp it. Anything else I can think of? Nope. Alright then. We're going to declare a few things here in our start function. Rot x is equal to 0, just making sure. And also I forgot to add in private rigid body RB. So we'll just do RB is equal to get component rigid body. And the other thing that we're going to do is we're going to set cursor dot lock state is equal to cursor lock mode dot locked. This just locks it into the center of our screen so that you get that nice first person look without having your mouse in the way. Now then, in our update function, we're going to call a function called handle inputs, and we'll make that void here. In this we'll need to set the value of a vector3 called move direction. So we'll say move direction is equal to transform.forward, which is the forward vector of our player, and it'll be which way we're facing. And we want that to be times by input.getAxisRaw vertical. So that's our W and our S key. And we'll just want to put that in some brackets because we're going to add it to transform.right, which is the right side of our player, times input.getAxisRaw horizontal, which is our A and D keys. And we're going to normalize it. Then we'll want to times it by our move speed, and last thing is set the y value to rb.velocity.y. Just make sure that we don't fall really slowly. So that's our move code, and in the fixed update, which is what you should always use for your physics kind of things, we do rb.velocity is equal to moved. Now we'll handle our camera movement in a function called handle cam. So make the function here, and for this we'll want to do .x minus equals input dot get axis raw mouse y, and then times it by the cam sensitivity dot y. Then we'll clamp it .x camx clamps dot x camx clamps dot y. Then we rotate our whole player, so transform dot rotate and we need to rotate on the y, so we set that to be input dot get axis raw mouse x times cam sensitivity dot x. And as for the player, not for the player, as for the camera that will be inside the player, we do cam dot local Euler angles is equal to new vector 3 0 0 0, and on the x we set our x, and that should give us some basic movement once we set all these variables. So let's go back into Unity, put the main camera into the player. Oh, hang on, there is one thing that I forgot. I forgot to set the cam variable. So cam equals transform dot find main camera. There we go. So now we can add our player movement script to our player, and you can see the rigid body has already been added. We'll just want to freeze the rotations so that it doesn't fall over. Set the move speed to 7, jump height to about 350, minimum slope angle to about 0.8. We haven't used those variables yet, don't worry. Cam sensitivity, I put it to about 7, find that to be good. And the X clamps, minus 70 and 70 I found to work well. So let's give this a go. Let's see how I've messed this up. Oh, before I do that, reset the position of the camera and just bring it up slightly. So, if you've done everything right, you should have a working camera and working movement with WASD. That's that part done. Now let's get some jumping into the game. So I'm going to make a private ball called grounded, and in the onCollision state, what onCollision state does is this event will fire every frame that we are touching a surface. So we need to figure out if we're vertical to the surface or if we're on a slope that we can actually stand on, and that's where our max slope angle comes in. There's this handy little function called a dot product, which gives you the angle between two vectors. So we would do our up vector, upwards of where our player is facing, but what should we use for our other vector? Well, we need to use the normal of the collision, which is why we do it in onCollision state, because this collision variable has our normal data in it. So we'll make float dot is equal to vector 3 dot 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 dot. collision.contacts, and we'll just do the first contact point dot normal, and for the second parameter our transform dot up. And then we'll set our grounded variable to be dot more than minimum slope angle, because perpendicular gives you a value of 1 and parallel, so just flat on the floor, would give you a 0. And for now we'll just debug.log grounded.string just to see if that's actually working. True. Seems all good to me. So this script does have a bit of a problem though. If we are constantly checking the first contact point, if that contact point is against a wall and all the other ones are on the floor, it'll still register as a false. So we need to find the average normal. And we can do that by making another float called total dot, set it to 0, and we will do for each contact point C in collision.contacts. So this will loop through every contact point, and we will just do total dot plus equals the normal of C. So then we can just get rid of that actually. We need to do total dot divided by collision.contact count, because this will give us an average. So we just make sure that this is set to total dot, and that'll give us an average. It won't be perfect, but it will be a lot better. And now we can do this. We can set up some jump code. If grounded and input.getKey down, keycode.space, and we will do grounded equals false, rb.add force, transform.up times jump height. Let's give this a go. If you press space now, you should have a little jump. We do have a bit of a problem where it makes us jump twice, and I will find us a solution to that because I don't actually have one yet. I'll think of something up. Okay then, we're back. I'd like to apologise for the first part of the video. I was not capturing my cursor. Sorry if that was a bit of a bother. But now we're going to get into the interaction system. I'm going to make a new script for the player. We'll call it player interaction. And basically what we're going to do is we're going to fire a raycast from the camera out to whatever it's looking at, specifically right from the center. And if it collides with an object that has our interactable script, we're going to interact with it. So open that up, and we will need a few variables to start. We want a private float to measure how far we can actually cast that ray. We will also want a reference to our camera's transform. We can do that ourselves. So in our update, we will want to send this ray out every frame. And while that doesn't sound like the most performant thing, it will actually be necessary for some of the stuff that we'll be adding in later. So every frame I'm going to do if physics cam.raycast. The origin is cam.position. The direction is cam.forward, I believe. Actually, let's just check that. Camera, yeah, it's the forward. It's the blue arrow. We'll also need a raycast hit, call it hit data. We need to make sure that we're outputting our data to the hit data variable. That's all we need. And we'll need to do if hit data dot collider dot compare tag player, and we need to make sure that that's if it's not player. Actually, we'll do a debug.log. We've done something wrong because it should not be colliding with the player at all. And if not, we'll need to do a type check. Instead of doing interact, we'll just debug.log hit data.collider.name. Let's give it a go. So nothing yet, but when we look at the floor, I think I might be dumb. Yeah, I might be dumb. Forgot to add in the script player interaction, and we actually also forgot to use the length. We'll just encapsulate this in another check. Hit data dot length. Here we are. Distance is less than raycast length max. Put that in there. And we also need a reference to the camera. Actually, use find instead. It's not the most performant thing, but it's fine as long as we're just using it in startup. And we'll set the max length to be something like 10. It should be majorly big. Nothing. And when we get close enough, it says plain. Alright. Now we can start actually coding the interactions. So we'll make a new subfolder in the scripts folder and call it base classes, because how we're going to do this, we're going to use an abstract class, which allows us to add in some code and some variables and then improve on that code, add more features to it in separate scripts. It's an organizational thing, and it allows us to group scripts together, which is quite useful when you're trying to interact with lots of different objects that have their own behaviors. So we'll call this interactable base. Open it up. And it's pretty easy to make an abstract class. You just type abstract. Unless you can't spell it properly, then you're done for. So in this class we're going to make these public. Public and int interact timer private int interact count, and we'll need a public void start interaction we'll want a bool interacting when we start the interaction, we'll set this to true. And if we do public void end interaction, we'll set interacting to false, and we're going to reset the timer. Interact count is equal to interact timer. So then in our update function, if we're interacting, we will start counting down the interact count. Interact count minus minus, and if interact count is less than or equal to 0, we will call our actual interact script, which is public void complete interaction. And in this we'll just call make a little comment, and we'll do debug.log completed interaction, put a little space, and we're just going to reset interact count again. I actually need to make this public, but we're going to hide it in the inspector with the header hide in inspector. We'll just want to put a public string name, or actually object name, and in this script we'll do if hitData.collider.gameObject.tryGetComponent interactable base, we'll just do interactable base interactor, and we'll set that in the tryGetComponent interactor.start interaction. Well, actually no, sorry, didn't mean to do that. Debug.log interactor.name. No, object name, because that's the one that we actually set. Okay, here's how we're going to do it. I'm going to make a private interactable base current interaction, and what we'll do here is we'll do current interaction is equal to interactor. If current interaction is not equal to null and input.getKeyDown, actually do this here, if input.getKey keycode.e current interaction dot start interaction, else current interaction dot end interaction. One more thing, just get rid of all that stuff And because we'll be doing this every frame, we can instead just oh, that's not good. Just do that. Let's make ourselves a little object that will have this script. We'll just make a little cube. And we'll give it... Actually, you can't put a base class onto a game object, so we'll just have to do base iterations, and we'll create a script called destroy on interact, because that's all this is going to do. It's just going to get destroyed. Basically, all we need to do for this is set it to inherit from interactable base. Actually, before I do anything else, these should be override voids, not override, virtual. So, add this script to your cube, destroy on interact, and it should have all these variables. So object name, test cube, interact timer, although actually interact timer shouldn't be 3, it should be something more like 300. Two, 3, 4, 5. There we go, completed interaction. So let's set up some UI that will help show this a little bit better. First thing you're going to want to do is create a UI canvas. We'll call it player HUD. We don't need the event system for now. We'll add it back in later. For now, make an image. This will just be our crosshair. And for now I'm just going to make it a red little cube. Not cube, square. And scale it down a little bit. Also, make sure that this is scale with screen size, otherwise you're going to have some problems later. And the next thing you're going to want to do is create a new folder, call it UI sprites, and you're going to want to import the ring object from the Google Drive that I'll be putting in the description. I have it here. It's this one. Set it to a sprite. Maximum size to 256. And this will be a new image called the interact ring. Add in this sprite. It should be a ring around our crosshair. Scale it down a little bit. Set it to be, I don't know, green. Actually, those colours are clashing a little bit. I might just set it back to red. And what we can do is we can set it to be filled, and we can have a little animation. So what we'll want to do is in our player interaction script, we'll want a reference to our UI image. You'll need the unityengine.ui for this to show up. Private image interact ring. And if we have a current interaction, set the interact ring, set it to true so that we can actually see it, and set the fill amount equal to, so to the current interaction, interact count divided by the current interaction.interact timer. That should work. Okay then, I was able to fix a small issue that was leading to the ring not displaying properly. It was because in our player interaction script we needed to change these to floats, because C#, if it's doing a division between two integers, the result will always be an integer, so it rounded up to either 1 or 0, which was not what we wanted. So set these both to floats, and this should be working now. Go up to this object, hold E, and it's done. As you can see in our console, the interaction was completed. So we are going to get rid of some of these debug statements because there's quite a few of them. Last thing that we're going to do is you need to make sure that in our start function that we set interact ring to false, so that we don't see it when we start up. Okay, now that we've got our interactions working, we're just going to make a last little thing that will show you how to use our abstract class. So this won't need any of the variables that we had before because they're all stored in our abstract class. All we need to do is say public override void complete interaction. And base.complete interaction isn't completely necessary, but in this case we're going to keep it because it's not actually damaging anything. What we're going to do, actually no, we're going to be destroying the game object, sorry, so we don't need it. All we do is destroy this .game object, and we will just change this to about 150, we'll half it. So now we go up to it, interact, and there it goes. Oh, that's a little bit of a problem. What we'll do is, since this gets unset, set current interaction to null, and get rid of that stuff as well. That should be working. Let's give it a test. I need to stop saying it should be working because most of the time it isn't, and I feel like I'm just setting myself up for failure there. But it is working in this case. Last thing that I'd like to do before I end this tutorial is I'd like to have some little text displaying what the object that we're hovered over actually is. So we're going to make some text, call it interaction text. We're just going to have it above the crosshair and the ring. Put it in the middle, and see, the problem with Unity's text is that by default it actually looks quite blurry. One thing that we can do to prevent that from happening, this is just something that I've found to work, is just scale it down a little bit and then use this scaling mode to bring it back up. Set it to best fit, and set this to just say null for now. Set the colour to the same as the crosshair, And that's all we'll need for that. Now we'll just go back into the player interaction script and we will serialize a field, private text, interaction text. And what we'll do here is if current interaction text is equal to actually in our interactable base we have our name already, and the other thing that we're going to do is we're going to make a text area public string tool tip. Actually we're going to call it use tip instead. Capital T. And what we're going to do here is current interaction dot name plus not semicolon, proper colon, and we're going to throw a /n /n plus current interaction dot use tip. And we're also going to set the game object to true. And if we don't have a current interaction object, set this to false, and just set the text to string dot empty. And that's just shorthand for doing the same thing, like that. But I find this easier to do, and I think it's just better coding, really. So we'll just set a use tip for the cube, just press E to destroy. We'll hook our player up to the interaction text. Let's give this a go. So everything disappears, and then we have our cube, press E to destroy. And there we go. That's our interaction system for now. We're going to add more stuff to it as we actually have things to add. And that's going to be it for this tutorial. I hope you all enjoyed. Next episode will be starting the inventory system, so I hope you'll look forward to that. For now, goodbye.